This is Math 2, 10.9 notes. That's Math 2, Unit 10, Lesson 9. And today's notes are titled Linear, Quadratic, and Exponential Models. I'm going to put notes here so you guys remember these are notes, not an assignment worksheet. Okay. You should receive this handout in class. If not, you can print it off of my website. These two you've dealt with in Math 1. You've graphed linear functions, you've dealt with exponential functions, and this year we've had quadratic functions, and we're going to compare the three. All right. When the x values in a set of data pairs have a common difference, you can analyze data numerically to find the best model. Okay, so here you can see all these numbers are increasing by 1. Negative 2 plus 1 is negative 1, negative 1 plus 1 is 0, 0 plus 1 is 1. So all of these x values are just increasing by 1 numerically on the number line. Now, you're looking for the pattern on the y side, and that's going to determine whether it is linear, quadratic, or exponential. Okay, so this is the one you dealt with last year. The y values have a common difference of 3. Can you see that? Negative 1 plus 3 is 2, 2 plus 3 is 5, 5 plus 3 is 8. A blank model fits the data. When it has a common difference, we call that a linear model. It could be plus 2, or minus 5, minus 5, minus 5. As long as it's a constant common difference, it is going to be linear. Okay, next one. You're multiplying by the same number. Can you see that? 0.25 times 2 is 0.5, 0.5 times 2 is 1, 1 times 2 is 2. The y value has a common ratio. When it has a common ratio, we call that exponential. So that's this one right here. When you're multiplying by the same number times 2 times 2 times 2, or times 3 times 3 times 3, or it could even be times 1/2 times 1/2 times 1/2, whatever you're multiplying by, if there's a common ratio, it is exponential. Okay, which our last one is a second difference. So a second difference of the y values. So you look at your first set, and you can tell you're not multiplying by a common number, and you're not adding by a common number. 1 minus 2 is negative 1. Negative 1 plus 2 is 1. 1 plus 6 is 7. 6 plus 10 is 17. That's not a common difference. But then you check here to see if there's a common difference. Negative 2 plus 4 is 2. 2 plus 4 is 6. 6 plus 4 is 10. If there's a common second difference, we say that is quadratic. All right. I want you to plot these on your own. Plot 1, 2, and 3, and it's going to be either linear, quadratic, or exponential. So plot each one. One of them is going to be a straight line. You're going to call that one linear. One of them is going to look like this parabola U shape here. You're going to call that a parabola. And one of them is going to look like this exponential function. Okay. You can do that one on your own. We'll compare it in class. Number 4. Which type of function best models the data in each table? All right. I just take a quick glance and check if I'm multiplying by a common number. 1 times 3 is 3. 3 times 3 is not 5. So I'm not multiplying by the same number. So let's check if I'm adding by the same number. A little harder to work with negatives, so you can check here. 1 plus what is 3? That's plus 2. 3 plus 2 is also 5, so let's check it here. Negative 3 plus 2. Negative 3 plus 2 is negative 1, so that works. Negative 1 plus 2, let's try it. Negative 1 plus 2 is positive 1, and that works. So it is a common difference. Plus 2 plus 2 plus 2 plus 2, which means this is linear. All right. Number 5. Excuse me. All right, so I'm going to check the same thing. 1 times 8 is 8. 8 times 8 is not 27. 27 times 8 is not 64. So I'm not multiplying by the same number. And since there's no negatives, I'm just going to check my common difference. 0 plus what is 1? 1. 1 plus what is 8? 7. Okay, there's not a common difference, so I know it's not linear, but I'm going to keep checking. 8 plus what is 27? You do 27 minus 8 and you get 19. And then 64 minus 27 and you get 37. All right, so we know it's not linear, but it could have a common second difference. So let's check that. 1 plus what is 7? 7 take away 1 is 6. 19 take away 7 is 12. 37 take away 19 is 18. There's not even a common second difference, so this would be a neither. Okay, so we're choosing between linear, quadratic, exponential, or neither. This is a neither because it didn't have a common ratio. We're not multiplying by the same number. It's not, it didn't have a common difference where we're adding the same number, and it didn't have a second common difference, so it's neither. All right, next one. 1 times 8 is 8. 8 times 8 is not 27, so I'm not multiplying a number. I'm going to start here. 0 plus 1. 1 plus 8 take away 1 is 7. 27 take away 8 is 19. And then 0 take away negative 1 is 1. Okay, so let's check. Negative 1 plus 1 is 0. 0 plus 1 is 1. 1 plus 7 is 8. 8 plus 19 is 27. Okay, so we know it's not linear. Let's check if there is a second common difference. All right. 1 to 1 is 0, or plus 0. This is a plus 6, and 19 take away 7 is 12. And there's no second difference either, so this is a neither. All right, so next one. 3 times 2 is 6, 6 times 2 is 12. Okay, it looks like we're multiplying a common number here. So let's try it. 3 times what? Or you can do 6 divided by 3 is 2. 12 divided by 2 is 6, so we're multiplying by 2. Let's test it. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24, and 24 times 2 is 48. So we're multiplying by a common number, a common ratio right there. So that is exponential. Okay. So we didn't see one here that was quadratic, but we will see some in our worksheet when we get working on it in class. So bring this with you to class. We're going to go over those 3 and do some like this on the worksheet. That is it for this lesson.